right, use these as your notes, as I just said to you. And I need you guys to, there's a couple of things that you need to do here. You need to tell me what the period is, you need to tell me what the amplitude is, the vertical shift, and then we actually have to graph it. So what I'm here is new information to you.
Plus 5.
Okay, in other words, which of these three things?
Vertical shift.
The vertical shift. Okay, and vertical shift literally just means that you take a graph and you
Shift it.
You shift it. Which way?
Up or
Five.
down.
Up or down. That's what vertical means. You shift it up or down. So not a big deal at all. But I'm going to show you some tricks that I think are helpful when you do this. So, first of all, let's find the period. Let's go back to what we talked about last week and find the period of this thing first. You find the period of a graph by doing what specifically?
Dividing a number with x by 360.
Okay, so you take 360 degrees and you divide it by the number that shows up right in front of the x. So 360 divided by 4 is equal to 90 degrees. So if you need to now take this 90 degrees, that 90 degrees means that you're going to have a complete rotation within the graph every 90 degrees. So it's going to be repeating itself very frequently. So if the period is 90 degrees and I'm asking you to divide it into 4 equal intervals so that you can get your 5 key points, how do you do that? What do you do to divide your period into 4 parts? Take 90 degrees and divide it by
4.
Take 90 degrees, divide it by 4. What is 90 degrees divided by 4?
22.5.
22.5 degrees.
Good job, Ricardo.
All right, so let's talk about that. 22.5 degrees. Well, 22.5 degrees means that you are going to have, at 22.5 degrees, you're going to have a point. So I'm going to put 22.5 right here. And then another 22.5 degrees is going to get you where?
45.
Going to get you 45 degrees. Another 22.5 degrees is going to get you at
7.5.
67.5 degrees. And then, of course, if you add another 22.5 degrees to that, you are going to end up at 90 degrees. So 22.5, 45, 67.5, and 90 degrees. What am I missing there? Because you're supposed to have 5 key points. There's only 4 values there. Yeah, I didn't include 0 there. So if you want to squeeze 0 in there too, you can certainly do that. What is the amplitude?
3.
The amplitude is 3. It's the number that shows up in front of the sign. So the
Plus and
amplitude is
negative.
equal to 3. The vertical shift. What is the vertical shift?
5.
The vertical shift is going to be a +5. So you take that graph and you shift it up 5 units. So the vertical shift here comes from this number right here. You shift the graph up 5 units. All right. Now we need to graph it. And this is my suggestion when you're graphing this thing.
We're finally getting started. Miss Corrigan, we would have been fine doing this hard.
All right, so what was the amplitude again? Because now I
The
don't have
amplitude
anything.
was
3.
The amplitude is 3. So that means that when I graph this, I have to go as high as 3 and as low as -3. That's what I would do normally. Okay, don't do this yet. Just listen for a second, okay, you guys?
Okay.
Oh, it was a sine curve, right?
Yes.
Okay, it was a sine curve. So that means, where am I going to start? Where do sine curves start?
0.
At 0. So you go from 0 and then you go up to a
Max.
maximum and then you go back to
0.
0 and then you go to a minimum and then you go back to 0.
It's just
So
gonna
this
be
is
an
what I
x-intercept.
think you need. This is what I suggest doing. Put your x-intercept there. Go over 1 step and go up to 3. Go over another step. Go back to your x-intercept. Go over 1 step. Go down
You're
to
throwing me off.
-3. Go over 1 step and then you're back at 0. So this is what and I'm going to connect these things with a dashed line because this is not what we're graphing. This is 3 the sine of 4x. I want to graph 3 the sine of 4x plus 5. All right?
Yeah.
So By the way, I need to put some labels in here too, because at first glance, I just think, oh, this must have a period of 360 degrees, but it doesn't have a period of 360 degrees, it actually has the period of 90 degrees. So what I'm gonna do at least is put a couple of values on my x-axis. I'm gonna put 0 degrees here. I'm gonna go over to here, I'm gonna go to the end. What is that end value? What is the number of degrees at that end value? It should be 90 degrees. And then I'll just mark, at least mark one more. I'm gonna put a 45 degrees right here. If you want to, go ahead and put in your 22 and a half and your 67 and a half. Don't have to label everything if you don't want to. But this is the deal. If it is helpful to graph a normal sine curve before you do your vertical shift, then do it. So now what I need to do is, because it is shifted up 5 units, what I need to do is take every one of my key points and I'm going to shift it up 5 units. And I'm going to do that with a different color because I can. Let's see. Just do black, I guess. So this point right here, which is at 0, I'm actually going to move up to 5 instead. I have to take this point and move it up 5 units. So here's 4, here's 5. So I'm going to take that point, I'm going to transfer it up to here. And then this point that used to be as high as 3, I'm going to now move up 5 more units. How high is it going to go? It's going to go up to 8. So this point is going to be moved up to here, up to 8, put a point right here. This point right here, which is at 0, needs to be again moved up to 5. This point, which is at -3, has to be shifted up 5 units.
2.
So you go to a positive 2, you shift it up 3 to bring you up to here, and then 2 more after that is going to put you about right here. And then you take this point right here, which is at 0, you move it up 5 units, brings you all the way up to here, and then you need to connect your points. And that might be the trickiest part is connecting your points, trying to make it look like it's supposed to look, and then still doing a good job of graphing it too. Not so bad, huh?
That's terrible.
Terrible. All right, I want to talk to you guys about, you guys immediately said to me, when I asked you what the period was, you said 360 degrees divided by 4, right?
Yep.
What is another way to do that? What if the problem was not in degrees is my point?
It would be pi over 2.
You would take, not pi over, oh yeah, it'd be pi over 2, yeah. Each step would not be pi over 2. So I want to talk about that. What if it was 2 pi divided by 4? What is 2 pi divided by 4?
1/2 pi.
Half of a pi, which is the same thing as pi over 2. In other words, the 2 over 4 reduces to 1 over 2, so it would be 1 pi over 2. So we have a period. This would be our period of pi over 2. All right, so what we need to do now is take this period, pi over 2, and divide it into 4 parts. Pi over 2 divided by 4. Well, you know what I suggest doing is just ignore the pi for a minute. Take a half, take 0.5 on your calculator, and divide it by 4. What is 0.5? We're taking a half of a pi divided by 4. What is 1/2 divided by 4? Get an 8?
No.
1/8.
1/10.
You get 1/8.
1/8, yeah.
Okay? So pi over 2 divided into 4 parts is equal to pi over 8. So that means when you guys told me it was each step was 22.5 degrees, 22.5 degrees is equivalent to pi over 8. So I want you guys to not be afraid of working on these things in radian mode. In fact, sometimes it's going to give you tricky ones like that that are not going to be in degrees, they're going to be in radians. I just want you to be comfortable with that. So if the first step was pi over 8, remember up above there you guys had to list 22.5 degrees, 45 degrees, 67.5, and then 90. What would you do here? If you had pi over 8 as the first step, what do you do to get to the next step? Yep, you'd add on another 1/8 of a pi. So an 8 plus an 8 is 2/8, which is the same thing as 1/4 of a pi.
Jeez.
So you'd have pi over 4. And then you would add on another pi over 8, which I believe then would bring you to
3 pi.
3 pi over 8.
Wow.
3 pi over 8. And then after that, you would add on another pi over 8, which would bring you to 4 pi over 8. Well, what is 4 over 8?
1/2.
It's a half, which brings you back to your 90 degrees.